Hello everyone. In this video, we'll provide the training course for the AWS certificate on Generative AI Developer Professional, where in this video we'll focus on Amazon Bedrock Knowledge Bases, RAG. Amazon Bedrock Knowledge Bases implement RAG, Retrieval Augmented Generation, giving Fusion Model access to your own data without fine-tuning. Your, you point it at your data sources like S3, SharePoint, Salesforce, Confluence, web crawlers, and it handles the chunking and the embedding and the vector storage as you can see in the image. Okay, in the data source here, you upload your documents. Documents are chunked and embedded in the vector store. Then the end user can search on this data where the search query is embedded into a vector. Okay, so that you can semantically search on the vector store here. Okay, and return is a response back and it's prompt augmentation. It handles here and it's input after that to the LLM and the end user get a response back. Okay, so we have two phases for data injection flow and text generation flow. Okay, this RAG. Actually, the workflow is your documents get chunking into smaller pieces. Each chunk gets converted to vector embedding, and those embedding are stored in vector databases like Amazon OpenSearch Serverless, Pinecone, Redis, or others. When a user asks a question, their query gets embedded. Similar chunks are retrieved, and the chunks are included in the prompt sent to the Fusion model, and the user gets a response back. As you can see in this diagram, this is the flow for RAG. Okay, the chunking. Okay, in this RAG, you can configure the chunking strategies. We have some strategies like fixed size chunks, semantic chunking, or hierarchical chunking. Fixed size chunk is simple but can split concepts awkwardly. It has a fixed size. It divides your documents into a fixed size chunks. It doesn't matter about the semantic, okay, of these chunks. But in semantic chunking, it tries to keep related content together in the chunks. Hierarchical chunking creates parent-child relationship for better context. You can see hierarchical chunks in scientific documents like metadata filtering lets you restrict which documents are searched based on attributes like departments, date, or document type. This is useful when different users should only see certain documents or when you want to narrow the search scope. You can see in the exam that some users they have security in other documents so that you can define metadata filtering so that you can restrict the search results. Knowledge bases integrates directly with Bedrock agents. So your agents can automatically query your knowledge base when they need information. You don't have to write the retrieval logic yourself. It's automatically retrieved by the agent from the knowledge base, as you can see in this diagram. Next, we'll talk about Amazon Bedrock prompt management. It's a version control and the governance for prompts. You create prompt templates with variables, version, theme, and deploy specific versions to production. This separates prompt engineering from application code. Okay, where you define different parameters for the prompts like temperature, top B, top K, maximum length, and this is actually an example of the prompt template you define. Next, we talk about a prompt template includes the prompt text itself, model configuration like temperature, top B, maximum tokens, variables that get filled it in runtime. You might have a template like summarize the following document. Okay, parentheses for document as a variable, where document here gets replaced with the actual content when the prompt is invoked from the user input. Versioning of these prompts means you can iterate on prompts without changing application code. Your application reference prompt by name and version, or uses the latest for development. When you improve a prompt, you create a new version and update the reference in your application code. If the new version causes problem, you can roll back by changing the version number back in your application code. You can also set up approval workflows. Prompts need to be reviewed before they are deployed to the production. This is quite useful in regulated industries where you need audit trails and change control. Amazon Bedrock prompt flows component in the Bedrock is a visual workflow builder for chaining multiple fusion model calls together. You create directed acyclic graph where each node is an operation calling a fusion model, transforming data, making decisions, or calling external service, as you can see here in the diagram for this prompt flow. Okay, defined in Amazon Bedrock. The use case is when you need multiple steps that depend on each other. For example, extract entities from text, then look up each entity in the database, generate a summary that includes database information, and formats the final output. Rather than writing orchestration code, you build this as a flow. Okay, it's no code. There is no code at all. Okay, you build it in Amazon Bedrock. Each node in the prompt flow can be Bedrock Fusion Model invocation, or a Lambda function call, or conditional branch, or a data transformation logic. You connect nodes to define the execution order. The output of one node becomes the input to the next node. Prompt flows in Bedrock handles error handling, retries, and state management for each state defined. If a node fails, you can configure retry logic or fallback passes. The flow maintains the state as it executes, so later nodes can access output from earlier nodes. Actually, this is similar to step functions, but specifically designed for generative AI workflows. It understands prompt templates, model parameters, and common generative AI patterns. For similar linear workflows, prompt flows is easier than step functions. For complex orchestration, definitely with parallel branches and sophisticated error handling, I will use step functions, so it will be better for these situations. Amazon Bedrock data automation is a very important service you can see in the exam. It's for processing documents at scale using generative AI. You point it at documents like PDF, images, scanned forms, define what you want to extract, and it uses fusion models to extract structured data. Actually, Bedrock data automation, the difference between the service and text extract is that data automation understands context and it can handle unstructured or semi-structured documents. But Amazon Text extracts text and identifies forms. But data automation can answer questions about the documents, extract specific fields based on natural language descriptions, and handle documents that don't follow a consistent template. You create a project, define the extraction schema, what fields you want, provide example documents, and data automation generates a model. The model processes new documents and outputs structured JSON with extracted data as a final result. It's useful for things like processing invoices from multiple vendors. Each vendor will have different format, extracting information from contracts, or analyzing research papers. The fusion model can understand that total due but might be labeled as total or amount due, balance, or something else. But the fusion model knows it. Data automation includes human review workflows. Documents with low confidence scores can be routed to humans for validation. The human feedback improves the model over time. Thank you guys for watching this video. I hope you like to this video, and you have any questions you can comment on this video and subscribe to my channel so that you can follow the future videos will provide. Thank you.